Alright guys, welcome back to Underground Science, and in this video we're going to be talking about, or not, or wait, never mind, we're not going to be talking about, we're just going to be discussing some basic examples of pH calculation so that we'll have a better grasp at it during titration and other acid-base calculations. Alright, so yeah, let's go and get started. So let's say we have, let's say we have an H3O plus concentration, right? Remember that represents acidity or pH below 7 of, like 4.4 times 10 to the negative 6 molarity. All right, something like that. This is our concentration of H3O plus. What are we going to do if we have to find the pH? So what's the pH? All right, so what's the pH? Oops, sorry, pH, not concentration. Just in general, what is the pH of the solution? All right. Well, the pH of the solution, an important equation that we should know is that the negative log of an H3O plus H3O plus concentration is equal to the pH. All right, not the pOH, the pH. All right, so here all we have to do is negative log of this value. So the negative log of 4.4 times 10 to the negative 6th, right, is equal to about 5.36. That's it. Sorry, I acted like it was something more, but 5.36, all right? That's the pH. This is the pH. So what if in the beginning of the question it asks you for the pH? What if we also had to know what's the pOH, right? What's the pOH? Automatically remember that the pH scale is of 14, right? Till 14. So the pH plus the pOH is equal to 14. Well, we just found the pH, so we can find the pOH, right? So just plug it in. So 5.36 plus the pOH is equal to 14. So the pOH is going to be 14 minus 5.36. All right? So that means the pOH is 8.64. So 8.64. So that's the pOH, and this is the pH, all right? So that's that, and if you want, you can even check. I mean, we did check. We know that the pH and pOH adds up to 14. All right, so if someone gave you the same thing, right, if they gave you the OH concentration and they told you to find the pH, right, all you have to do is the negative log of the OH. You know what, let's just go and do that. So let's go and do that example. So what if we gave you, right, what if we had the OH concentration is, let's say 3.9 times 10 to the negative 9th, all right? And then what's the pH, all right? So what is the pH? Well, here we do the same thing, so let's go and start. So the negative log, it turns out the negative log of the OH concentration is equal to the pOH of the solution. So the negative log of 3.9 times 10 to the negative 9th molarity, or moles over liters, right? Don't know what that was, sorry about that, is equal to about 8.41, all right? So this isn't the answer though, guys. This is the pOH, right? It's mainly the hydroxyl concentration, representing the hydroxyl concentration, or the alkalinity. What's the pH? That's the whole scale, right? The pH scale, which adds up to 14, or which it goes to 0 to 14. So we have to write out that equation. So remember the one we just did above, the pOH plus the pH has to equal 14. So that means that 8.41 plus the pH that we're trying to find is equal to 14, not 114, sorry about that, 14. So that means the pH is going to be 14 minus 8.41, which is about 5.59, all right? So which is about 5.59. So this is the answer, right? This is the pH. Don't get confused like, oh, okay, so this is the answer because this is the pOH. That's not the pH, all right? pH is 14 minus the pOH, all right? And then that's going to be equal to the pH. All right, so that's that. And we already went over autoionization examples, right? OH times H plus, OH negative times H plus equals 1.0 times 10 to the negative 14th. Just feed in the value to find one or the other, right? So this is pretty much it. So this is how you work around when you're given the concentration of OH or H0 plus, and you work around to find the pH or the pOH. So another quick thing, so just remember that the negative log of any H3O plus concentration is going to be equal to the pH, and the negative log of any OH concentration is going to be equal to the pOH. But what happens when I give you the pH and tell you to find the H3O plus concentration? All right, so let's say this example. So if I give you the pH is equal to, I don't know, 5.5. All right, so what is the H3O plus concentration? All right, well, if you already know the equation, you just have to plug it in and solve it, right? So negative log of H3O plus is equal to the pH, right? The negative, when we already gave you the pH. So the negative log of the H3O plus concentration is equal to 5.5, right? And then all we have to do is so then divide the negative 1 on both sides, so we get rid of the negative. So log of H3O plus is equal to negative 5.5, right, guys? And then what you do is, based on the properties of log that we have, the same thing as writing 10 to the negative 5.5 is equal to the H3O plus concentration. And then you just do 10 to the negative 5.5, and then you have this, right, the H3O plus concentration. So that means, so if we go in and solve it out, the H3O plus concentration is equal to about 3.16 times 10 to the negative 6 molarity, all right? So what we saw here, what do we see here? So if we're given the pH and we have to find the H3O plus concentration, right? We saw that we can do 10 to the negative pH to find the H3O plus concentration. So that's another equation. 10 to the negative pH is equal to the H3O plus concentration. So either you can remember this equation also, or you can just remember this equation and they'll work, and you can solve even questions like this where they just give the pH, but you'll just have to solve more. All right. But if you want to, you can remember this equation, you can solve it faster. Given the pH, just feed it into here and find the H0 plus concentration. Or you can work it out and get to there also. It's either way is fine. So if we said that 10 to the negative pH is equal to H3O plus, we also have an equation that's 10 to the negative pOH equals to the OH minus concentration, right? And let's see how that works. So let's go and just change this example to what if the pOH is 5.5? What's the OH, right? So what if someone gives you that? So another example would be, what's the OH concentration, or not like this, but what's the OH concentration when the pOH is, I don't know, 6.5, right? So what is the OH concentration this time? They're not asking for H3O plus, they're asking for OH concentration. And they also didn't give you the pH, they give you the pOH. But you do the same thing, right? Because now you remember your other equation, which is negative log of OH minus equals to the pOH, right? Well, I already have the pOH here, so I'm just going to feed it in. Negative log of OH minus, our hydroxyl concentration represents alkalinity, right, equals 6.5, all right, sweet, log of OH minus, get rid of that negative, right, negative 6.5, and then based on the properties of log, right, based on the properties of logarithms, you're going to write 10 to the negative 6.5, right, bring this as an exponent, on the base 10, equals your OH concentration, right? And so now you just solve again. So the OH concentration, OH negative concentration, right, which we're trying to find here, is going to be equal to 10 to the negative 6.5, which is about 3.16 times 10 to the negative 7th, all right, molarity. Same thing here, guys. Either you can just remember this equation, right, and solve it out, or look what we did here is that we did 10 to the negative pOH equals OH concentration, which is this equation right here. So either way works, all right? Either remember this way and just solve it out, or you can remember these equations, right, for a more shortcut way. All right, but whatever works for you. So that's pretty much what I wanted to get through in this video, some example calculations for the pH, right, and different scenarios. So hope to see you guys in my future videos where I'll talk about more cool topics about bio, biochem, chem, and physics. Make sure to hit that notification bell so you know when I'm publishing my future videos, right? And don't forget to hit like and subscribe. And see you guys later. And stay safe.